Hello guys, welcome. In today's video we are going to talk about decorators. So a decorator in Python is a function that takes another function as its argument and it returns the another function. So decorators are extremely useful as they allow the extension of an existing function without any modification or changes the source code of the original function. Basically, we can assign our function to any variable. So all the things that contain in our function, as long as the memory location of both the variable and the function is same. So we can use the function as the variable. So let's move towards its syntax now. So let's suppose I am going to create a program to square a number. So I am going to square is the name of the function and a is suppose is the argument of the function. Now what I have to do, I can return with exponent 2 and then I can call our function. So but as we are discussing about decorators, so as we have discussed, we can assign our function to a variable. So I am going to assign this as variable our function. The name of the function is sq. So instead of calling my function, I can just call my variable s, and in the argument suppose I am writing 2, so the square of 2 should appear at the output. As I run this program, you can see that 4 is appearing at the output. So our function, so basically s is the decorator of function sq here. Now let's proceed further. So we have an example program to make square of atoms in a list by using function as an argument. So we have to discuss an example to the example which takes a list as an argument and a function. Now let's proceed this example. So I'm going first for I'm going to create a list which contain 5 elements, 1 2 3 4 5. So I am going to create a function. So the name of the function is my map. All right. So in this function, as we discussed in the example, that there are two arguments. First is a function itself is the argument, and second is the list. So I have to process the function that each atom in a list should be squared and appear in at the output. All right. Now so I have to appear, I have to store each atom squared in a list. So I'm going to create an empty list, and then I'm going to use for loop for I in L, which is the argument, and I'm going to append each atom in N. So as I have to use the function, so I am using func. So whatever the function I will give in an argument will be append in the list n. All right. So it will there are so many, we are using list to appear at the output. So the output will be appear in a list data type. So I have to use I here. Right. Now I can just return n here, and then I can just call my function which is my map, and the first argument is function. So instead of creating another function, I can directly use lambda, which is one line function we have discussed in previous videos. So I can directly square suppose a, and I am exponented by 2. So it is our first argument, which is lambda function, and the functionality, it is squaring the variable a. And then the second argument we have is L, this L, which contain 5 elements. And as you can see, if I again run this program, you can see that each element present in a list has been squared. Now the let's proceed. The second, we have the function return the function by using decoder. So basically in this part we are going to learn that how decoders work when we are using function inside the function. All right, now let's discuss it. So now let's proceed this example. I am going to create two functions. Number one is the outer function, and I'm going to the second function we have is the inner function. All right, this is basically the nested function, and inside the inner function I'm going to print a message that inside inner function. So this message is in the inner function, and uh, then I'm going to return inner. So I can just directly return the inner function, and whenever we are using nested functions and then we are using decorators, so the outer function must be, so that if the outer function won't call, the inner function cannot proceed without the outer function. So as we are using decorators, so I'm going to assign my outer function in a variable. All right, and then I can directly call my variable here. And as you can see, if I run this program, there is an error. Yes, I should not using the brackets here. And then if I run this program, it is, yes, I must, there is inclination problem. And then in this program you can see that inside the inner function is appearing at the output. All right, now this is simple. Now we have another example that we have to print a message by using the decoder. So we have discussed the functionality, that how can we use function inside the function, and now we have to print a message. Basically we can just modify this program so we can understand this example to print any specific message. So any message that we want to print, we have to print in the inner function. So I am using string formatting. The message is msg. So in the outer function, I can directly write here the message, which is suppose I do. All right, now as you can see, if I run this program, so the message is hi do should be appear at the output. There is another error. Yes, I should not use the parenthesis here after the, because I am not calling the inner function. I am directly calling the outer function with the argument, with the message basically, and store it in a variable. So basically if anyone put here parenthesis, so it will generate the error, which is type error. So now the output is clear. The message is hi do. All right, now let's proceed further. So we have an example program to take a number and its power. We have to take two things, a number and the power of the number, using the decoders. Now what I have to do, I'm going to create a power is the for outer function, and basically the number, I'm going to call it number, is another function. Now they both takes two arguments. So suppose power is x and the number is n number. All right, now what I have to do, we process our the structure or the body of the function must contain in the inner function, which is the inner function we have is number. Now in I can directly return n with exponential x. So x is the power and n is the number, and I can directly now return my number. So I should not use parentheses, which we have just faced an error. All right, now I'm going to store my outer function, which is power, in a variable. So I'm going to call it a variable var and store power. So I'm going to I have to give the argument. So the suppose the power is 3, and if I am going to call the variable here, so I must need to give in the second argument, which is the number. So suppose the number is 2. So the power of 2 is the power of 3. 8 should be appear at the output. So if I'm going to run this program, you can see that yes, 8 is appearing at the output. So our task here is accomplished. Now we are proceeding further. So the example program, we have done this example to take number and its power. So we have it is important that how decoders that we are discussing right now enhance the functionality of the function. So as we discussed at the earlier of this video, that we can as we discussed at the start of this video, that decoders return another function. So let's consider an example. So I'm going to return the function, another function basically. So if I'm going to create a function called decoders, and inside the decoder I'm writing the argument, which is another function. Alright, now I am going to create another function called wrapper, and then inside the wrapper, basically wrapper is our inner function, so the body must contain inside the inner function. So I'm going to create a this function is awesome. So this is the message, and then so now instead of using decoders, I can directly call any function. So I am writing here any function, and then I am calling it by using these parentheses. So it means that it is not the function's name is decoder, it is the argument of the function that is calling here. So, and then if I am going to return my inner function is wrapper. So I should not use a parenthesis after the wrapper, it will generate an error. And then I am going to create another function. So if I want to use the functionality of this function in another function, so basically if I use decoders, inside the decoders this whole function is proceeding. So I just need to use the decoder. So as we are going to discuss that how the decoders, or how the not the decoders, they are the decorators, how the decorators improve or enhance the functionality of the function. So that's what we are about to learn. So I'm going to create a function called func. This is a simple function, and then inside this function I'm going to print a message called this is function 1. Alright, this is the function 1, and now I'm going to call this decorator. So as we discussed, when we are using decorators, so we store these outer function in a variable. So decorators function, I'm going to store it in a variable. So this basically now we are taking it as an argument, because we are going to give this function as an argument of any function. How? So I just need to write here func. Func is the function which is predefined. We have defined by using the def keyword. So I am giving this function as an argument for the outer function. So basically if I just call the variable var here and run this program, you can see that what is these two lines, this function is awesome and this is function 1 is appearing at the output. So basically what is this line is doing? Any function. So any function is the argument of the decoder, and then we are calling decoders in a here. So if I comment this line, you will see that this line this is function 1 will not execute. We are calling wrapper here, you can see that we are wrapper, and then in return we are the wrapper function is called here. So this must be appear at the output. This is awesome. This function is awesome. But when we are using decoders, a decoder function is not called here. Instead, its argument is being called. We can see that any function. So if I comment the any function, which is the argument of the decoders function, and if I again run this program, you can see that this is awesome. This only line, this is awesome, is appearing at the output. This whole thing is being vanished. Why? Because when we are calling this function, any function which is the argument of the function, we can use this as to call the whole decoder function. So that wherever the decoder function is being called, it will be appear at the output. So where we are calling it here decoder, and we are storing it in a variable. And inside the decoder function, we are giving it as an argument of the function, which is the func. And this function is printing this is a function 1. So this is the whole structure of the program basically. So if I'm again run this program, you can see that any function is calling decoders, and decoders, wherever the decoder is being called, it should appear at the output. So I hope and another thing I want to discuss, if I don't want to using decorator, basically what I'm saying, that I don't want to store my function decorator in a variable. I just want to call this function. I don't want to involve this outer decorators function in my this function func. So what I can do, so there is another thing. If I remove these two lines, and in just before this function, if I write here decorators, so I can so these decorators automatically call this function, whatever the name of the function. I can by using the @ I can call this function. If this is @ basically we use it when we are using decorators. All right, now I can just what I need to do, I just need to call my function. So by calling this function, the output will remain the same. So as you can see, if I run this program, you can see that there is no change in output. Why? Because I am calling decorator function by using that the rate here. So this is another thing. If I comment this code decorator, and if I again run this program, you can see that it will not calling, it is just calling this function. This is function 1, and this whole, because decorator is not being called here, so the wrapper will not be called, because wrapper is the inner function of the decorator basically. So basically we are just defining this function. This is the only function we are defining. So this is function 1 will appear at the output, as we discussed when we were learning def function. So what is decorators is doing, so basically by using the @ decorators, I am calling my outer function decorators to print both functions, wrapper and func. So I hope I am able to clear this. That's all about today. We will discuss more about decorators in the next video. Thank you very much for watching.